Hello everyone, welcome to this video. In this video, we are going to cover end-to-end post creation project using a AWS Bedrock. So why I am choosing the AWS? Because if we want to create some sophisticated applications, we have to choose a services such as AWS or Azure. So in this video, I will focus on the various services provided by the AWS. The first one is AWS Bedrock, second is AWS Lambda, third one is a DynamoDB, and the last one is a API gateway. So all these services are having some charges and you have to look into it. But if you are new to this, the Amazon will pay you a free tier. So if you are working within it, you will not be get charged for anything at that moment. So now we will focus on what are the each terms in this each service covered in this video. So first is Amazon Bedrock. So basically the Amazon Bedrock is the easiest way to build and scale a generative AI application with the foundational model. So basically it provides n number of foundational model, maybe by a Meta, Amazon, etc. and that we can use. And the main advantage which we are going to take in this is nothing but it provides a serverless LLM. So what is the advantage of serverless LLM? If you are not directly building very huge application which will be run continuously in the background. So the advantage the serverless LLM provide is that it will be charged only when you are going to use it. So you don't have to think about many things. All the servers are being maintained by the AWS itself and you just have to use the service and use it in the serverless mode. The second thing which we are going to use is the AWS Lambda. So basically the AWS Lambda provides a serverless computing, and in this we can write a code which we can use for any integration. So basically for invoking a model on a AWS Bedrock, we are going to use this AWS Lambda function, and you can write the code in either Node.js, Python, Go, Java, etc. So you can choose any language. So that is the advantage of using AWS Lambda. The next service which we are going to use a AWS DynamoDB. So whenever we create a post, we want this post to be stored somewhere. So that is why we are going to use the AWS DB so that we can create a table and store all the data. So whichever topic we want to choose and what is the post it is creating, that we can easily store in a DynamoDB. So what DynamoDB is, it is again a serverless NoSQL database. So again, you don't have to think about how to maintain that server. It is been maintained by the AWS itself. So that is the another advantage of using this. And the last one which we are going to use is a AWS API gateway. So API gateway provide you a single link or where which we can use a post request to initiate this Lambda function. So this is what we are going to use it for, the create, maintain and secure API at any scales. So these are the various services we are going to use to build our end-to-end project. So how it will be connected to each other? We can see over here, initially our model will run in AWS Bedrock and it is been invoked using AWS Lambda function. And whenever it is going to generate a response, it is going to store that response in AWS DynamoDB. And how we are going to access this Lambda function is using a API gateway, which will generate an API which we can use either in Postman, or you can build your any front end whatever you want, and you can use that API in your front end, and all this will be your backend. So now we are going to see how in a step-by-step way we are going to achieve this. So first of all, I would like to open a server. So first of all, you will have a console whenever you go into the AWS. The AWS will provide you this home console. It may be slightly different for you, whatever recent things you have used for this. Now in this, what we are going to do is, firstly, we have to check out what is a Bedrock. So you can type over here a Bedrock. And when you go into the Amazon Bedrock, you have to go to the model catalog. So basically there are different models been provided by AWS, in which we are going to use a serverless only, because for other things it will be continuously running in the background. So that is why we will use a serverless model, and there are many 47 serverless model currently provided by AWS. Now in this which we want to use, so I would like to prefer suppose a Llama model. So in the Llama model, there are different versions. So suppose if I wanted to use a 70B model, so for that you have to first make a request. So you can see over here, it is written as a access granted and it is written as a available for a request. So if the access is not been granted to you, if you are using it for first time, then you will not have a access. So you have to ask for that access. So for that you can click on a model and you have to click on available for a request. Then go for the request model, and again as you want to access a request, again click on, we are looking for 3.170B instruct model, and again go for a request. Now these are which models which I already have a access granted. Those are 1 billion, 3 billion, then 70 billion, for which I am right now having requesting an access of. So I will just click on next and click on submit. So this access will be immediately granted to you. So you can check it which model you have access of. So now it is showing that 70 billion instruct model I right now have access of. Now we want to check which model will be more suitable to us. So it is not like that if we are having all the models, we have to use a best model. So we have to check that which model is having a less number of billion parameters and which are satisfying our purpose. So such model will be best to choose for. So now if I want to use this 70 billion model, I have to just open it. Whenever you open it, it provides you an option that you can open it in a playground and you can directly have access how you can use it. So just open it in a playground. Now here you can write a prompt and have anything, so whatever you want to write over here. So now we are using it for creating a post, a LinkedIn post for a related topic. So for that you can have a prompt over here. You can tweak what should be a temperature, top P parameter, max length it can generate. So I will increase it slightly. So such parameters you can define over here. Now if you want to choose which model will be best suitable, which is having a less billion number of parameter but should also perform better way, so it also provide you a compare mode. Now in a compare mode, I will select a small model. Suppose I will select a Llama 3.2 1 billion model, which I already have access. If you don't have, you can request for it. So again, this setting, I will keep it as same. I will slightly increase the max length which it can generate. Now I want to write a prompt. So what a prompt to be? So write a LinkedIn post for the topic. I will write LLM as service. So this, for this topic, I want it to write a post. So just hit a run button. Now same prompt will be run on both the LLM. Now you can see that the 1 billion has given a response in very quick time. As it is having a less parameter, it will always be a quick model. So you can see over here, unlocking the power of artificial intelligence, the future of LLM service. And you can see over here how it is written the title, the future of AI LLM as a service. So again, both the model has written a good kind of a post, but we can see over here even the 1 billion model has written a good post. So for this application, it is not needed that we should use the 70 billion model. We can work with only 1.1 billion model also, and it will also is giving us a good result. So For this application, I think Llama 3.2 1 billion model is enough to get a required output. So in these things, we are going to select this model. Now to use this model, it is not a good thing to come into the playground, write your complete post. You have to build a complete application. So now for building this application, what we are going to do, we are going to write a code in a Lambda function. So for that, you have to go to the Lambda, and in Lambda function, you are going to create a new function. So I will just click on create new function. I'm going to write it from scratch. The name of my function will be a LinkedIn. And the things I would like to use is nothing but a Python. So I would like to use Python 13 as a runtime on which I can write a code. Then you have to click on create function. So it will give you a complete overview that what this function is called of. This is a basic syntax which it has already incorporated, where there is a Lambda handler. So basically a Lambda handler is a thing which actually going to invoke your model and provide you a response. So in that particular thing, we have to write a few things into it, and for using a Bedrock model, we required a Boto3 library. So we have to import those library. So you can write it over here, import Boto3. Then we are going to import Boto core. And for saving a date and time, I am going to import date time also from datetime, import datetime. So this is how you can import a various library into your Lambda function. Now we want to generate a text. So for that, we are going to define generate text, or generate response, we can say it as. So now instead of writing whole code, I will just take you to a code which I have already written. So this is the code which I am going to use. So it is first we are going to define a generate text, and that in that we are going to pass a topic. So topic on which we have to create a post. Then in that topic, I am going to write these few things. What should be my topic? Then from this topic, I am going to create a prompt. So the prompt which we have just written, that write a LinkedIn post for a topic, and we have to pass this topic. So this will become our prompt. Now we have to set a model ID. So now I will show you how you can use this model ID. So in this, first I will just open a Bedrock once again, and to show you how you can have a exact model to be called in your Lambda function. So for that, again we will go to the serverless thing, and the model which we have selected is a Llama 3.2 1 billion instruct model. Now in this, if you came at the bottom, there is a API request usage. So how you can going to call this model is given over here. First thing is a model ID. So if you want to invoke this model, you should have this model ID. This model ID you are going to write in a function. So model ID is equal to, now I have added US, you can skip it also. So meta.llama 3.2 1 billion instruct model. So why I added this US is basically all the models which are been provided to you are based on the region, and the region I am using is a US East 1. So you have to provide this region also for the most of the time. So that is why I have added it as a US dot this as a model ID. Now what is the next thing we have to provide? Next thing is a content type, and the content type it is following is application JSON. So that we have to define. the application type is equal to application.json. The next thing we are going to provide is a accept function. That accept function is also given over here. This accept function is also application JSON that we have right over here. And next we are going to form a body. So for a body, it should follow this instructions. That body should contain input, and the input you are going to provide as a role as a user, content, and how it is been written. And if you are having like a chatbot, you can have a multiple instructions provided into this. So role user, role assistant, again role user. So you can have a sequence of a chatbot history like things that you can pass. So if you are building a similar kind of model, you can write it in such a way. And at the last, there are the parameters. So what are the max number of tokens it should generate, what is the top P, and what is the temperature. So these are the optional parameter. Either you can pass it or you can skip it. It will use a default values. So right now I am going to skip it, and I will keep a body as json.dump, and I will write it as a prompt is equal to prompt. So basically most of the parameters or most of the model follow exact same sequence. So you have to try it out. If this input as a prompt works, you have to write over here as a input, and then you have to pass a prompt. But I tried this model and the input thing doesn't work, so I am passing the prompt. Now you are define everything to invoke the model which we have selected in a Bedrock. So we want this model to generate a response. And to generate response, we are going to use a Boto3 library which we have imported. So we will write try this Bedrock is equal to boto3.client, server name is equal to Bedrock runtime. So you can check out over here Boto3. The Amazon has provided complete code how we or documentation how we are going to use it. So I will search over here as a Bedrock, and this Bedrock provides a Bedrock runtime environment. And in the runtime environment, there are many functions which we can use. We are using in this project the Bedrock model, invoke model, because we want a generated post only. So if you want to have a chatting experience, in that you have to use invoke model with response stream. So you can see it typing the things from the chatbot. So in that case you can use it, and there are many other functions been provided. Now in this we are going to use invoke model. So how invoke model works, the Bedrock runtime.client invoke model, and we have to pass the parameter, and this is a exact syntax. So whole syntax you can use, on which we are going to use a body, content type, accept, then model ID. These things we are going to use. Guide rail is one of the important thing, but we are not using it in this model. So this is the syntax we are going to require. So this is the syntax which I have followed already in these things. So this is how we are going to generate a response, and how this response will be passed. So I will just show it over here how we can do it. So either we can do it directly in a Lambda function, or we can write it in any editor. Right now I am choosing a Google Colab. So first of all, you have to install this Boto3 and JSON to check how our response is being generated, so that we can format it. So after that, you are going to require some key points, that is this access ID and secret key. So I will show you how you can generate it. So for that, initially I will just use this code, and we can simply paste whole code into our Lambda function. So I will just replace this code. I will explain the whole code to you once it is been completed. So this is for the generation, and we have passed all the things: body, model ID, accept, and content type. These things we have passed, and we are generating the response over here, and all the generated response will be stored in a response body. So this first, initially the response is stored in response, and what response content is used over here. So now before that, I would like to show you that if you want to run this in outside environment, you will require some access key. So for that, I am going to first of all deploy this. So here you can show the model is been deployed, and after this model is been deployed, we have to add a API layer. So what basically the API layer is? API layer is going to give you, suppose I will just write over here API gateway. So this API gateway is what we are going to use it. And this API gateway provides you a single LinkedIn post server. So it is already created. I will just delete it. And we are going to recreate these things. So I will go into the create API. In create API, simply I am going to use a HTTP API. So we can build this, and in HTTP API we can add the integration, and for this integration we are going to have a Lambda function. And which Lambda function we are going to use? From US East 1, we are going to choose a Lambda function which we have just created. So this is the LinkedIn Lambda function which we created. So this integration we are going to form. Then you are going to click on next. We require this API name. So API name I will like to write is as LinkedIn API, and we will click on next. So we will keep it as default, and instead of any, we are going to use a post request. So that we will select. Then click on next. Keep it as a default. Again click on next and create. So this post has been created. You can have this ARN which you can use, and you can configure all those things. So before that, we have to configure our Lambda function. So if you go into the, again, this Lambda function, we have to configure. Here you can see this API gateway, but this API gateway does not have enough permission to use it. So you can see over here, this is the ID which it is been generated. But if you will go into the permission, there are some permission which is required. So for that, we are going to go in a LinkedIn console, and in this you have to add some permission. So I am going to click on add permission, and just click on attach policy. And here right now I am going to provide a administrator access, but in most of the cases you will not get directly administrator access. You have to add one by one. So right now, for a simplicity, I am completely going to provide a administrator access to this function. Now this administration access is been provided. Now if we go back to this Lambda function and just refresh it, so all the permission is been provided to this Lambda function. Now as we see over here, we have created given all the access to this Lambda function. But if we want to use it outside a Lambda function, what we required, we will require some detail of access which we want to provide. So for that, I will go into the user and I will create one more user over here. So here I can define a LinkedIn as a user. Then go to the next, and I am going to attach a policy directly, and I am going to provide a full administrative access to this user. And I will create on next and create user. So I have created this LinkedIn as a user, and for this user I have to provide some access key. So this access key I will use for a command line interface, and I will click on I understand and click on next. So description value, no need to provide, just click on create access key. So this is the access key, and this is I am going to store in my Google Colab credential. So if I go into this, I have to save this into my credential. So suppose I will write it as a LinkedIn access key, and I will paste this credential. And the next thing which we want is nothing but our secret key. Now you can download it in a CSV file because it will only be shown once. So I will just write it as a LinkedIn secret key, and I am going to paste it over here. So now I have to use both of this key. So I will just turn those key on. I will just copy this name and I will just replace it. So in access key, I want to use this one, and for a secret key, I want to this secret key, and you have to run it. So in this way, you can use your access and secret key by which we can access that account. Now we are going to import all this library, and these things I have already defined. So we will run this code. So now our prompt is been stored in a body. Now we are going to use this Bedrock Boto3 invoke client, where you have to pass a region, access key ID and access key secret. But if you are writing it in the Lambda function, you are not supposed to write it because the Lambda function has already access which we have just provided to it. So in that thing we have write just a Bedrock service only. Now we can generate a response over here. I will just run this command, and it has generated this response. Now you can check this, it has response to various things. So out of those things we required a response which is stored in a body. So we have to access this body. So that is why we are going to run json.load response body, and we have to read it. So we will just run this command and we will see what it actually print. So again it prints one JSON file in which the model or all the response of a generated LinkedIn post is stored in a generation. So we have to use this generation as a print. So you can see over here, this is what LinkedIn post is being generated. The AI of the future of AI, the text, benefit, etc. in such a way our LinkedIn post is been generated. So now we are going to see how we are going to import it in a Lambda function. So I will just again show you our Lambda function which we have created. So in this Lambda function, first of all, we are going to generate the thing which we have just generated, and we have stored the response in a response body, and response body generation. This is what we are going to return. So this will be return of a generate text function response. So next thing what we are going to define, we have to store it. So in a Lambda body, we have a body which is been coming from the event, and in event it is stored in a topic. So this will be our body topic which we are going to pass it into the generate text command, and it is going to generate a response in generate post. And this post we will return over here to a API request. But we required one more thing, we have to save this response in a DynamoDB. So for that we are going to write one another definition to save post. What we will require, we have to generated post, we have to post save it, and topic we have to save it, and we will save it based on the timestamp on which it is been generated. So for that, first you have to use a Boto3 to access your DynamoDB, and in a DynamoDB you are going to use a table, which table will have this title as a LinkedIn post. So till now we haven't created this table. So first of all you have to go to the DynamoDB. So you can write it here as a DynamoDB. I will open it in a new tab. So this is a DynamoDB environment where you have to create a table. So go to the table, click on create table. Name should be a same name which you have provided in your Lambda function. And all the things, what is the partition key? So partition key which we are going to use is nothing but a first thing, that is a timestamp. This we will use it as a partition key. So we will store it over here. Then sort key is optional, we will not provide it, and keep all the things default and click on create table. So it will take some time for creation of this table. We will just go through our code. That then what things we are storing, we are using a command table dot put atoms, and we are going to put atoms timestamp, then topic and post. So these are the things we are storing it, and we have to return true. So whenever we run this save post command, our post will get saved in our DynamoDB. And whenever we are going to run this complete things, what we are going to require, we want it to respond us a generated post. So that is what we have responded. Now the thing is that when this table is created, we can just go in and we can check there are no current atoms count present over here. Now the link is been provided by our response that we can simply copy, and we have to paste it in our postman. So in a postman, you can have it as a post request, and you have to paste your link over here. And in the body part, you have to pass a raw data, and that raw data we will just right now use the prompt as topic trends in LLM. So these things we want to generate, and we will simply click on send button. So right now you can see over here there is some internal server error. So to resolve this, we have to make some changes into our Lambda function. Now you have to go to the configuration. If you want to check what actually happened, we can go into the watch, cloud watch. In this cloud watch, we can actually check what things goes wrong. So in this, you can go into the log group, and in a log group, you can check this group is created, that is a Lambda LinkedIn. So this is a function which is we have invoked. So here you can see there are many logs is been generated. So in a report, it is shown as status is a timeout. So it is not given that it is not spending enough time and we are getting a timeout. So we can change it using general configuration. The timeout is just a 3 second. So as we know, our Bedrock model will require a more amount of time for generation of a code. So I will just increase it to 1 minute, and I will save my model. Now again we are going to check the same thing. We will again open this postman and we are going to send a request. Now you can see it is taking a time, and previously as it is just 3 seconds, it is not able to generate any response. So now you can see over here our response is been generated. Now we can check it in our table also. For a table you have to go to the DynamoDB. We have already created this LinkedIn post. Now initially still it is showing as a 0 count. We will just click on get live count. So it is showing that there is a live count atom as 1, and we can explore these atoms also. So click on explore table atoms. So in table atoms you can see there is a one entry over here, and this is a timestamp. Then what is the topic trends in LLM and the post, and this whole post is being saved over here. So in such a way you can create a complete application using your Bedrock. So this is how we have implemented our postman to API gateway to the Lambda function. It will access a Bedrock model and store the post into a AWS DynamoDB. I hope these things is clear to you. If you are having any doubt, you can comment in a comment section. So thank you for watching this video.